Hello and welcome to the long-awaited second video on vectors. So our very first video we went through this. We'll just recap that very briefly. We said that in order to be able to analyze a frame that looked like that, we needed to be able to draw vector diagrams. And so we start with the space diagram, which gives us information. We then draw the vectors to scale, and we put a first vector, and then the next vector goes at the end of that, and then the next vector goes at the end of that. And the line from the start to the finish is our resultant. And if you remember, we said that that is a vector because it has a size and a direction. That isn't a vector because although it has a size, we don't know which direction it's going in. So it's important that we put the arrows on things. We also said that bit.ly/S teacher was a good resource to revise our vectors. Okay, and we said that if we had three forces acting, 1, 2, 3, again we draw them to scale, so that means we draw them to a size, and we also draw them in the same direction as we're told in the space diagram, and it doesn't matter what order we do those vectors in, as long as we do each new vector starting at the end of the old vector, we get the same resultant force, as we can see there. And that's more or less where we left it. We went into that in a little bit more detail. So today, you see all those letters as I'm scrolling down. We're going to look at why we put those letters in there. That's the first thing we're going to look at, and how we do that. And that's called Bow's notation. Okay, and it becomes useful as we start to do our vector diagrams. Okay, so Bow's notation. We label the spaces. And you look at this little diagram here and you think, well, what does that mean? Where are the spaces? So it might help, just until you get used to doing this, it might help if we just put a circle, or an oval in this case, around there. And then we can see, can we embiggen that any? Can we embiggen that? Oh, look at that, beautiful. We can see we've got 1, 2, 3, 4 spaces. And so with Bow's notation, we label the spaces. We're not labeling the lines. We're labeling, we're labeling the spaces. So let's have a look at what that looks like. So there's space A. I usually start by the first space between our two reaction forces, reaction force 1 and reaction force 2, or reaction force A and reaction force B if you prefer, or left and right, but reaction force 1, reaction force 2. So the first space is space A, and that's between our two reaction forces. Okay, so I'm just going to copy and paste, and then I work around clockwise. Okay, so that's A, B, and C, and then our final space is in the middle of the frame. So let's just bring that up there, space D. Okay, so we've labelled that as you would Bow's notation. So let's have a look at how that might work for a slightly more complicated example. So just paste that in there. So again, I'm going to start by labelling the space there. Let's draw a circle around it just to help. Yeah. Obviously, once you've got used to the Bow's notation and how it works, you don't have to draw a circle, you don't have to draw a circle around at all. Just helps you visualize perhaps what's going on a little bit more. So there's our first space, space A. And now let me just copy that. There we go for space B. Shift and B, there we go. Oopsie daisy. Control Z, Control Z. B, there we are. There's B, okay. There's C, the next one round between our two loads. Yeah. Whoopsie daisy, don't want to do that. There's space D. Okay, so we've just gone round clockwise, and then we're going to just fill in these here. So that's going to be E, F, and G. So we're labeling the spaces. Yeah, just remember, it's not the lines that we're labeling, it's the spaces. Yeah, I've labeled those spaces. And that's how we do Bose notation. If you look and do a bit of research at Bose notation, you'll see it's done in various different ways, from people doing A, B, C, D for the outside spaces and then using numbers for the inside spaces, or they might go A, B, C, D for the outside space and then go 1, 2, 3 for the inside spaces. This is the most consistent way I do it. It works for me. So start between your reaction forces, go around clockwise, and then fill in your spaces in the middle, and just stick with the alphabet, because then we can have letters for our spaces, and when a little bit later on, when we start looking at the joints, we can number our joints just to make life a bit easier for us. So that's Bose notation. This helps us keep track of what we're doing as we go along. And it doesn't really matter if you say went Z, X, Y, or I don't know, used emojis, or as long as you're consistent throughout, as long as whatever you label here then informs the rest of your problem solving for this. Okay, so maybe have a practice of that. Draw yourself out a little. In fact, I shall prepare one for you now. So, in the best traditions of TV, here's one I prepared earlier. So, just spend a few moments, just pause the video, copy that down, and label that up with Bose notation. Okay, and when you've done that, press play again, and we'll put up the solution and see if you've got it right. Okay. Okay, welcome back. I'm trusting you've done that by yourself. So shall we see what that looks like, and you can check. So we've got A, there's B. Okay, you'll notice I'm not putting the circle around this time, but if you've drawn yourself a small circle around just to help you out, then that's fine as well. Okay, C. D, A, B, C, D, E, F, G, H, and then there we go. So yours should look something like that. And if you've got some of the letters in a different place, it doesn't matter as long as we've got a letter in each space. Okay? All right, you might have done A, B, C, D, D, E, F, G, H, I. And that's fine, as long as each space has its own letter. And for Bose notation, I'm not sure if I said before, we use capital letters, uppercase letters. We use capital letters, uppercase letters. Okay, and that's what we use for Bose notation. So that's Bose notation. So hopefully we've got our head around that. So what do we do with Bose notation? We'll get to that in just a moment. Okay. Okay. So as we've said, looking at the spec, it says that we have to solve this graphically. And what does that mean? It means we don't use any maths. Well, we do use maths, we use geometry, but we don't use any calculations. We just draw lines on a piece of paper. So let's just expand on that thought. What do we mean by that? Well, we can solve graphically. We can find both these reaction forces, and then we can find the forces in each of these members, and we can find out whether each of these members is in compression or tension. So how do we do that? Well, the first thing we do, as we do with all vector diagrams, is we draw what we know to scale. So the only force that we know from this problem is that 10 newtons. So let's just snap to grid there. So let's just count 10 down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we are. So we've drawn that to scale, 10 newtons. And now what do? But now we'll pick what's called an origin. So I'm just going to draw that as a small circle. Okay, we just pick an origin point. Okay, so there's our small circle. And the origin point can be anywhere. It can be here, it can be here, it can be here, it can be here. It could probably be over there. But I usually put my origin point to the right and slightly down, because I've found that then when we go on to the next bit, all my extra drawing that we're going to do comes below my space diagram. Okay, and I think that just makes things slightly less confusing. So we've picked our origin, and now we draw lines from the start of our vectors and the end of our vectors to the origin point. Okay, so that's what I've done just there. And you say, but Steve, what happens if we have more than one load on our structure? Well, I'll just show you. Okay, so just a quick example just to show how this goes if we've got more than one load on our structure. So we've got two loads here. So let's give them a value, shall we? Very quickly. So 5 newtons there, say, for example. And let's just copy that. And let's say that that's, I don't know, 12. 12's a good number, isn't it? 12 newtons. So what do we know? We know 5 newtons and 12 newtons. What can we remember from our vector drawings? We draw what we know to scale, and each vector continues from where the last one left off. So 1, 2, 3, 4, 5. And then, oops daisy. Let's get me copy and paste command sorted out. There we are. And then 5, 6, 7, 8, 9, 10, 11, 12. So we've drawn them to scale end to end. We pick our origin point. Oopsie daisy. There we go. Pick our origin point, and then just like before, we draw lines from the start of our vectors to our origin point, and from the end of our vectors to our origin point. So that would look like this. Okay. All right. So let's just focus on the simple one at the moment. I'll just keep flicking back to the slightly more complicated one, just so we can see how that differs. But I'm going to just mostly focus on this here. So this is where it gets tricky. We've got 4 or 5 steps that we need to do. Okay, so the first thing that it would be useful to do would be to just put in some construction lines. So I'm just going to make that dotted. Obviously, if you're doing this by hand, you could do that in faint pencil or something. So I'm just going to do one of those, and then I'm going to copy that and paste that. And we've got another faint construction line there. Okay, so these are just construction lines, and they're the lines that of the force. Yeah, so they're in line with the force. Yeah, if we extended the force line, the load line, or the reaction force line, that's what we'd get. Okay, so that's the first thing we need to do. You're right, we could put one here, but this is always our starting point, so we don't really need to. Starting point for what, I hear you ask? Okay, I'm going to color coordinate this now. Let's have a nice shade of orange. Okay. So the first thing we do is we measure the angle of that line, and if we're using a protractor, we just need to be consistent. Yeah. So if we put our protractor horizontally, yeah, and we measure this angle, then when we draw our line again, we measure that angle. Yeah. If we put our protractor there at that point and we measure that angle, then when we need to draw the line parallel, we measure the same angle. Okay. If we held our protractor vertically, yeah, we could measure that angle, or we could measure that angle. As long as when we draw it again, because we need to draw a line parallel to the orange line, we measure the same angle. Okay, that's the important thing. So where do we need to draw this line parallel? Well, we need to draw this line parallel through that starting point there until it hits this extension line. Okay. Okay, so now let's make this a nice pretty colour. Green, I think. So again, I'm drawing a line parallel to that from where the orange line intersects our extension line, again up until the point that it meets the next force extension line. Okay, and from there we draw another line. It's line-tastic, isn't it? We'll make that purple, and we do that from that point there. So I'm going to snap for us. No, we're snapping to grid, close enough. Back to the start. Okay. Maybe if I turn the grid snap off, maybe that'll snap for me. No, it looks a little closer there. Back to the start. And then we draw a line parallel to the purple line back through our origin. Okay, so that's back through our origin. And where this point is here, where the purple line crosses our original vector, that shows us where the reaction forces are. So from here to this point is one reaction force, and from here to this point is our second reaction force. Okay, so, and that is how we graphically find our reaction forces. So let me just show you what that looks like for the slightly more complicated example. And then I'll stop this this one, and we'll continue to delve into this in the next screencast. Bite-sized chunks and all that. Yeah. So again, we do extension lines for each force after the first one. Okay. So let's choose some colours again. Shall we go with that orange again? Yeah. So our first force goes a parallel line from the start point until it hits that extension line. Okay, our second force, let's go for that nice green colour, why not? Our second force, parallel again, and that comes from that point down to where it meets this extension. Okay, yeah, so that's keeping that parallel. Obviously I might have changed it a bit because I'm snapping to a grid, but you'll be using a protractor and therefore we're more accurate than me. And then finally we have our third line. So you see we go between these extension lines of force. Let's go for that. There we are. Okay, and that comes up from there again to where it meets there. And then finally, we draw a line from, where's the dark half? There we are. We draw a line from that intersection back to the start. And let's make that nice purple colour. And then we draw a line parallel to that line through our origin. Okay, so we can see that that's the first, so from here to here, going up, is reaction force 2, that reaction force, and from here to here is reaction force 1. And that's what that looks like. Right, I'm going to stop there, and in the next video we'll just quickly recap this, and we'll look at how we apply Bose notation to this process, and then what we do next. Thank you very much.